It is a solution of higher mathematics for class 10 under the syllabus of Board of Secondary Education Manipur. Solution Larik asi class 10 gi Board of Secondary Education Manipur na phongba textbook higher mathematics adu solution amani chapter matrices and types of matrices and chapter cd matrix amasung mahaki makhan sing duni solved, reported, and presented by Salam Sundar Singh, lecturer, Sultan Higher Secondary School in Pan. Matrices. Chapter Sida and the matrix service quick combination. Matrix. A rectangular array of mn numbers arranged in m rows and n columns enclosed in a pair of brackets is called a matrix of order m by n or m by n matrix. mn numbers to rectangular mawongda sindokpa m rows ta amasung n columns ta sindokpa pair of brackets na enclose question ba adugumba mawong amabu aikoina matrix haina kawgani m by n gi matrix leiba matrix ama kawgani. Suppose each number in a matrix is called an element or entry of the matrix. Matrix amadi yauriba number khudingmakpu matrix adugi element natraga entry hana khangnagani. In general, an m by n matrix is written as general by m by n matrix is. This is called a11, a12, a1j, a of 1n. This is called first row. Elements are separated by giving space. Tongan by elements in khangnabagidamata point marak space bigini comma halfway. Then a of 21, a of 22, a of 2j, a of 2n. In the second row hana khangnagani. Then asum lakona a of m1, a of m2, a of mj, a of mn. In the m row hana khangnagani. The order C m rows lere is called first column, second column, j column, n column. Number of columns to n even m by n the m china number of rows ni adu n china number of columns ni. Elements are separated by giving space piraga tongan by elements in khangnagani. Adu maraka comma signal boundary symbol d c square bracket chini. In compact form, matrix A assume even A of suffix ij. General element symbol A of ij, Aij have a C, Aij have a C element occurring in the ith row with the column level element to A of suffix ij na khangagani. Matrices are denoted by capital letters, capital A, capital B, capital C, etc. Matrix symbol English my key English alphabet ki capital letters in a matrix symbol mamin khangnagani. The boundary symbol of a matrix is square bracket. Bound matrix amagi boundary symbol d square bracket na khangnagani text asida. The horizontal lines of the elements are called rows. Masibo ikoi horizontal lines singa sibo ikoi na rows khangnagani. Karambana row oigani here. Masida sigi elements in sigi elements like a parts row khangnagani. Sigi elements in sina parts row by koina kari hai na khangai capital R mana. Sigi sina second row khangnagani. Second row and the suffix sina number of row khangnagani sina second row. Sina ikoina sina second row khangnagani. Second row R capital R suffix 2. Asumna matang lakpana sina m row khangnagani m row. Mabarakta row mayam ama lahore. Sigi row asubo ikoina row m row capital R m khangnagani. Then amuksu sigi sina first column khangnagani sigi vertical line sina first column is capital C1. In second column khangnagani sigi element sina second column C2. Asumna matang lakpana sina j column khangnagani. Sina j ani suba suffix sina j column khangnagani. Sina icona C j. Then sina end column n suba column khangnagani. sꯤꯁꯤꯅ ꯑꯩꯈꯣꯏꯅ n column cn ꯑꯁꯤꯅ ꯏꯒꯅꯤ The vertical lines of the elements are called columns. Some are first column, second column, z column, n column. A capital small a suffix ij denotes an element lying in the ith row and j column. I sub row with j sub column the element to a suffix ij na khangagani. Matrix service rectangular arrangement of numbers mean it has no value. Types of matrices, matrix rectangular matrix. Any m by n matrix is called a rectangular matrix. M by n matrix, m by n की order level matrix, rectangular matrix को है row column मशीन माना जाता मरुएना या क्या row out row row अने column machine 1 first column second column third column सुनना m by n matrix rectangular matrix को square or rectangular को है जो मशीन rectangular है row machine column machine माना जाता इसको खाना गने matrix की definition है rectangular matrix है कि बने any form square or the square have a two rectangular the particular case amani to one from a single column a single manageable in a kangarani adu putana yemura but yemuragadi roma sing mana the sugo column mana the rectangular thing square matrix any n by n matrix is called a square matrix of order n or n row square matrix roma single column a single manable matrix to square matrix code again this is how many rows, first row, second row, third row, how many rows, 3 rows, first column, second column, third column, number of columns is 3, therefore number of rows is also 3, number of columns is also 3, the two are equal, therefore it is a square matrix. Row matrix, a matrix having a single row is called a row matrix. Row amakaptang layba matrix to row matrix kawe, any number of columns layba actually row amakaptani columns 1, 2, 3. Row amakatong lerabadi any number of columns lerabadi sumadu row matrix called column matrix. A matrix having a single column is called a column matrix. Column amakatong by any number of rows lerabadi su. Column amakatong level matrix kudaman si column amakatong row masindi 1, 2, 3. Column amagu lerabadi any number of rows lerabadi sumadu column matrix called diagonal matrix. A square matrix is said to be a diagonal matrix if all its elements other than the diagonal elements are 0. Square matrix amagi diagonal natabula element punamuk 0 orabadi. Puramana sigi square matrix ni square matrix ni. Square matrix sigi sino diagonal matrix to achno diagonal code. Sigi aina angang mo na ilibay elements sino diagonal elements ko. The two diagonal elements sino diagonal ko. At pa diagonal ko na maming ko main diagonal o principal diagonal ko. Sigi diagonal na tabulay element ko na mag-zero square matrix na mabuhay ko na diagonal matrix ko. Sigong ba diagonal na ilibay elements sino mana bayay mana raga na wala nga ko ba Managana atopo one natab atopo and number loin or VI. Manager CI, diagonal natab element, square matrix, samagi diagonal natab element, punum of 0 over matrix, amabo, icona, diagonal matrix code. Scalar matrix. A diagonal matrix whose diagonal elements are all equal is called a scalar matrix. Mata kiasida diagonal matrix asigi diagonal element number scalar number ama oid loina mana rabadi diagonal matrix amagi diagonal element punam to 1 ngato 2 ngato 3 ngato -1 ngato -2 ngato loina mak mana rabadi madu scalar matrix koi scalar habidi angkada number habini number ama 0 natab number ama ngaka oirabadi loina mak 0 natab number ama oirabadi scalar matrix koi. Untuk example, ani semua ni C2 ngato oi, C1 ngato oi, -1 ngato mana scalar matrix ko. Identity matrix. A diagonal matrix whose diagonal elements are unity is called an identity matrix or unit matrix. diagonal matrix amagi diagonal level element punamo 1 ngakto oibabu aikoina unit matrix natraga identity matrix kawi 2 oiba 3 oiba 4 oiba di scalar da singai but unity di 1 ngakto oiraga di madugi special maming aikoina identity matrix or unit matrix hana khangnagan Ramon C 1 C 3 by 3 square matrix में square matrix से diagonal से और है scalar से और है identity matrix और non matrix or zero matrix have a matrix all of whose elements are zero is called a non matrix or a zero matrix matrix amagi element punamuk zero or body matrix to non matrix not a zero matrix called matrix adu any order rectangular or square or Remember, see matrix 3 by 3 square to square or square or the docte element punamuk 0 or the upper triangular matrix. A square matrix all of whose elements below the principal diagonal or main diagonal are 0 is called an upper triangular matrix. Triangle amagi square matrix amagi mathakta leiba square matrix amagi mathakta makhada leiba principal diagonal gi makhada leiba element punamuk 0 orabadi principal diagonal main diagonal amagi makhada leiba element punamuk 0 orabadi matrix to upper triangular matrix called lower triangular mathematical a square matrix all of whose elements above the principal diagonal are 0 is called a lower triangular matrix. Triangle asigi principal diagonal asigi mathematical element punamuk 0 or a square matrix asibu in a lower triangular matrix called equality of matrices matrix manaba. Two matrices are said to be equal if they are of the same order and their corresponding elements are equal. Order manabak aduga mapatana element punamuk manarabadi matrix ani adu manaba matrix koi. Thus, two matrices A whose element is Aij and B whose element is given by B of suffix ij are equal if they are of same order have received m by n or above m by n or order manaraba. And their corresponding Aij equal to Bij for all I and j. Corresponding events managadavani, orders managadavani, matrix samidu mane and hygiene. Matrix ni mane hygiene they have same order and their corresponding events must be equal. C matrix and C part C element C. C matrix C corresponding C2 C manare, C3 C muk manare, C4 C manare. Corresponding C0 C manare, C2 C manare, C6 C manare. So corresponding given C corresponding C corresponding C. Corresponding Soloina manare. Theory do not much below. Exercise 5.1 matrix. Matrices and types of matrices. Matrix You can see question number 1. Consider the following information regarding the number of boys and girls reading in class 10 in 3 schools A, B, C. Makhagi school alone see the class 10 the number of information C. Schools A, B, C, number of boys 26, 35, 42. Number of girls 31, 27, 32. Adobe A. Heavy school C, number of boys 26, number of girls 31. B. High by school C, number of boys school number 30, class 10 at number 30, number 35. C. High by school C, number information 42, 22. Represent the information in the form of a 3 by 2 matrix. Pyramid by information 3 by 2 matrix represent to heaven. Matrix service is a matrix a number? No, matrix service number are not. Matrix give a lot of information. Matrix micro tongan po The required representation is this. As matter table as even represent to what does the element in the second row and the first column represent? Second row ki ahanba column da leba elements na kari represent hoge. Second row haibadudi ekoina mathematics in a first row ko second row ko third row ko. So second row ki first column da second row ki first column da leba element second row ki first column da leba element hari first column mein second column mein sigi element second row gi first column level circle portion level element sigi magi mathau adudi magi mathau sigi 35 feet part second row gi ahan ba column level element in sigi 35 sigi ma arch karina 35 is the mathaki table at the school will be the number of boys 35. The number 35 represents the number of boys in school B. Number 35 is in school B the common class mahutsil masing thang. Let AIG is equal to this 1 2 first row, second row, third row, 4 row, first column, second column, third column. Find the order of the matrix. Matrix is order put to have any matrix of 0 masaki and 1 2 3 4 row masing 4 ni column masaki 1 2 3 3 ni adu the matrix of order is 4 by 3. The order is 4 by 3. Gonna find A of 2 3 A of 2 3 की value kaya no हमने A of 2 3 की value दी A of 2 3 की value दी matrix की table सीधा A of 2 3 अनि सुबह कलम की अहम सुबह element अनि सुबह कलम की अहम सुबह element हरे गदी अहम सुबह element हरे गदी सी की number 6 असना करी दी तो सी ने मतलब द सी ने मधुना कना की value no मधुना सी की value ने मतलब द A of 3 2 हाइब्रिडी अहम सुबह रोगी अनि सुबह कलम में element दी A of 3 2 की सी और मतलब A of 3 अहम सुबह रोगी अहम सुबह कलम में element सी आज ने कना को represent तो बने इन माह की value ने A of 4 1 मरी सुबह रोगी आहान कलम में value -2 और सी माह की value ने the A of 4 2 mari sugar rogi ani sugar column the element have the -2 na the value this maybe A thus A of 2 4 exists ani sugar rogi mari sugar element have the mathematical like the bani adu madu like the order is 4 by 3 and A of 2 3 ani sugar rogi of element -6 A of 3 to the ahum suba column the ani element 3 gani or madam the A of 3 to the ahum suba row the ahum suba column the element I gani A of 4 1 mari suba row the aham element the -2 gani mari madam the A of 4 2 have the mari suba row the aham column ani suba column the element the -2 gani thus A of 2 4 must A of 2 4 like the abidi ani mari sugar rogi mari ani sugar rogi mari sugar element hai like the maram column singo ahu tole gani na column mari sugar brain state the type of this following matrix makha ki matrix si ki type hai usi number row masingo column masingo mane square matrix square matrix is number of rows equal to number of columns. Ani suga asigi this square matrix with diagonal natab diagonal natab element punamuk 0 or banina square matrix or diagonal matrix is is square with non-diagonal elements are 0. non-diagonal element punamuk 0 or diagonal matrix or ani suba sigidi main principal diagonal ki makhada element punamuk 0 or the upper triangular matrix or upper triangular matrix is it is square matrix with lower diagonal elements are 0. Next the column column matrix as it has only one column. Next the row matrix as it has only one row. Any number of column layer. Set the type of the following matrix as C matrix, C 0 matrix pulling mark, matrix C element punamuk 0 or MSC 0 matrix or non matrix 0 matrix or as all elements are 0. Next, C diagonal square matrix ni half the principal diagonal ni mathak element punamuk 0 or the lower triangular matrix always. Lower triangular matrix as it is a square matrix with upper diagonal matrix. Upper triangular diagonal elements are 0. Next, number 8. diagonal matrix square the square matrix में scalar matrix में no scalar matrix not the diagonal matrix square as it is a square matrix with non-diagonal matrix are all 0. Non-diagonal element for 0 or a square matrix or a diagonal matrix square. Next, the scalar matrix square. Scalar matrix as all diagonal elements are equal to a scalar as well as it is a diagonal matrix. A matrix A has 24 elements. Find all possible orders A may have. Matrix among element 24 lay mahaki utopia orders to possible orders of a matrix having 24 elements are 24 have carbon and they are called orders of A. 24 have 1 by 24 over 2 by 12 over 3 by 8 over 4 by 6. 5 particularly 6 by 4 and I by 3 and 12 by 2 and 24 by 1. I think you matrix that can be a matrix. You can be a matrix. TV matrix any SC order. TV matrix of intersection for company. TV any SC intersection for company. Then see the order of along with intersection for the order of along with intersection for the order of along with intersection. If A has 7 elements, what are the possible types A can be of? Possible orders of matrix having 7 elements are 1 by 7 and 7 by 1. 1 go 7 go 27 type, 7 go 1 27 type. Atopa natural number ni 27 tablet maram di mark prime number ni na. So possible types of the matrix are a row matrix or a column matrix. Find the 3 by 3 matrix AI suffix ij where aij is given by 2 times of I minus j. So Roman number 2 aij is given by twice I plus j. Next, A11 to CG. General element in another formula so palaga. A11 I am so I don't want period J1 period 3 I just 1 period J1 period. Simplify to the 0. A of 1 2. I don't want to see log J the 2 to log we get minus 2 pang A of 1 3 haragadi A I don't want J the 2 to log C I can simplify to minus 4 pang. Assume 3 by 2 near the A of 2 1 to see I the 2 to log J the 1 to log simplify to 2 pang in the A of 2 to the I the 2 J the 2 to log 0 pang A of 2 3 the I the 2 J the 3 and will be minus 2 pang. Assume that 3 by 3 to go 3 3 by A of 3 1, A of 3 2, A of 3 2 matang sinas no putok si. Hari will mention si pattern asida matrix CMC. The required matrix K first row to be first row 0 minus 2 minus 4 assume the second row to be 2 0 minus 2 irani. Third row to be 4 2 0 assume the similarly Roman number 2 sumagi general element putok na formula to palaga. A of 1 1 the I am the matang no 1 1 2 simplify to loma pangane A of that is 3 pangane A of 1 2 haraga the I the 1 the 2 kisilog simplify to 4 pangane A of 1 3 the I the 1 the 3 kisilog simplify to 5 pangane matang the A of 2 1 I the 2 kisilog the 1 kisilog simplify to 5 pangane A of 2 2 I the 2 the 2 kisilog so I the 2 the 2 kisilog simplify to I pangane A of 2 3 the I the 2 the 3 kisilog simplify to 9. That's what 3 by 20 as the A of 3 1 the A of 3 1 I the 3 kisilog the 1 kisilog simplify to 7 pangane A of 3 2 I the 3 the 2 kisilog simplify to I pangane A of 3 the I the 3 the 3 kisilog we get 9. I will mention so for the requirement is to be 3 4 5 no possible 5 8 10 5 8 9 sina marine 7 this must be 7 must be 7 or element 6 7 or 7 thamani assume na then 7, 8, 9. This is the required matrix. Matrix. Number 3. Aij is I plus 2ij by 3. Here Aij is I plus 2ij by 3. Assume A of 1, 1, I was J to 1, 1, Pichilla simplify the rows. A of 1, 2, I to 1, J to 3, Pichilla will be equal to 5 by 3. A of 1, 3, I to 1, J to 3, Pichilla 7 by 3. And the A of 2, 1, I to 2, Pichilla 0 to 1, Pichilla simplify the row 4 by 3, 4 by 3. Then A of 2, 2, I to 2, J to 2, Pichilla be equal to any Marie Mongatar, and the A of 2, 3, I to 2, J to 3, Pichilla simplify the row A of 3, 1, 3, 2, 3, 3 to 20. So we 3 by 3 elements in the row of the therefore required matrix are due to 3 element 1, 5 by 3, 7 by 3 first row the irony, 4 by 3, 2, I by 3 in the second row the irony, 5 by 3, 7 by 3, 3 as in the third row the irony. Required matrix to assure Aij is given by I minus j whole square by 2. A1, 1, I to 1, J to 1, law, and mark value 0 pangane. A of 1, 2, I to 1, J to 2, 0 simplify to half pangane. The A of 1, 3, I to 1, J to 3, 0 simplify to 2 pangane. Pass row equivalent to popular. A of 2, 1, I to 2, J to 1, law. A of 2 to D, my value pangane. A of 2 to D, I to 2, J to 2, simplify to 0. A of 2 to half pangane. A of 3, 1, 3, 2, 3, 3, required matrix to be 0, half, 2, 0, half, 2. It must be half, or whatever. It must be half. 3 elements is 3 half of 2. So the half, 0, half. In the 2, half, 0. Number 5 similarly A of 1, 1 between I to 1, J to 1. A of 1 to the I to 1, J to 2 pixel simplify to A of 1, 3 the I to 1, J to 3 pixel the first row dimension, second row, third row, fourth row, third row put one. Then required matrix position 0 minus 3 minus 6, 0 minus 3 minus 6. Karamna fangi si value city si value si amato sana the requirement is the lala. C matrix of C values में 0 लगे CD minus 3 होगा बने. This must be minus 6 होगा बने. This must be 2. This must be minus 1, this must be minus 4, this must be 4, this must be 1, this must be minus 2. I will the matrix of system easy 0, minus 3, minus 6, minus 6, 2, minus 1, minus 4, 4, 1, minus 2. From the sum token I am the respective value simplify the requirement is the following equality possible for any values of x, y, z. Makagi matrix and C manner of the x, y, z value for any value that Sungola. That TMC matrix ni 2 by 2 ni C 2 by 2 ni the corresponding manner the corresponding manner corresponding manner of the x plus y ni C manner ni x plus 2y z 5 manner equation to y plus z is 4 manner ni manner of the 3 letter. Then matangi y plus 2y it must be 2y. The value C X over now we solve the C 4 equation 4 dagi equation 1 khaido ko x ani si x and y value to si x to te ahan daga 1 da singular y value 0 pa ang value si equation 2 da singular 2 dagi kaya not to the x to value to singular this singular z value to si z value 1 pa when x or y equal to 0 and z equal to 1 in equation 3 y am sin z value to 1 da sin 0 plus 1 and right now 4 is 1 equal to 4 must be chunde which is false must be equation solved over the form of the solution gonna see the single matamda see the single matamda lale the tirami ba x and y je ki value pumna mana mata equation is chuman mangamde thus there is no possible values of x y and z x y z ki akakna ba value parana mata akakna ba value sing mata equation inde non value lobe yade find ABCD pyramid equation se manare ABCD puto unknown mari ni unknown mari se the mark again condition mari khange a plus b na 5 ko mano equation 1 a b plus c na 5 ko mano equation 2 a plus c na 2 ko mano hello equation 3 b plus c na 2 ko mano hello equation 4 c equation mari se unknown ABCD puto kani an bada ai karam mo ko kani question 1 dagi 2 khado 1 dagi 2 khado ko di mangare a the c the equation number 4 a equation c over equation 5 figa a equation c over equation 3 figa ani c c over 5 to 6 na a point adding tawrani a gi value puto kan a gi c ma halaga a gi value 2 phang thangai 2 gi a gi value was equation 1 da singular a gi value equation 1 da singular but d gi value was 5 minus 2 that is 3 then equation 2 da to the b value 6 value I join c value to 1 because a congress b congress c congress b putono gi the most equation 4 signagan equation 4 da b value 3 b value 3 pishula d because b value minus 1 value mari di a value na 2 or any b value na 3 c value na 1 b value minus 1 value mari cinematic equation so many atopa a b c d value cinematic similar. Find the values of x, y, z in these two matrices. Matrix and isi manner pyramid corresponding manner equals to 1, y plus z equal to 5 equals to x plus z equals to 4 equals to 3. Okay, I unknown often solve to equation and it's the current amount of y plus z value not y plus z value equals to 2 to 1 this is 1 in 2. Equation 1 to 2 this is 2 this is the x value. Sorry no. Y equals to 1 the value 2 the value to 1 is 2 the value to 5 y plus z matrix is the 5 and 6 that x below 1 like equation 2 no 1 is the equation 2 na 1 da that is 1 day 2 5 ci and x value kang x value to matrix equation 3 is the lot to z value to no z value 3 kang x something that you look already y value the master equals to the lot to the z value 3 to the y value a to unknown of the x value no 1 y value 2 z value 3 any more combination equals to 1 to 2 to more different ways we're gonna x y is solved over find the value equation is manner iconometric manner of the corresponding value manner corresponding value manner with x minus y no 1 manner twice x minus y no 4 manner equals to twice z and 3 manner hello 0 0 to come up and around equals to 3 z value to off z by 2 z value as a amo tradition yadre other 1 2 ga ani si hydroner 2 the 1 hydro pro x and no with them 4 the 1 hydro pro 3 x and then only x value to 1 the last 1 is the value y value as the alternative. Therefore, x value 3 or any y value 2 or any z value 3 by 2 or any z value from 3 by 2. Equation I. Equation of unknown of equation of x plus y not 5 y plus then 7 z plus x may I equation 3 equation of ꯑꯩꯈꯣꯏꯅ x y z solve ꯇꯧꯕꯒꯤ ꯃꯗꯨꯒꯤꯗꯃꯛ 1ꯗꯒꯤ 2 ꯈꯥꯏꯗꯣꯛꯈ꯭ꯔꯣ ꯀꯔꯤꯒꯤꯗꯃꯛ y ꯃꯥꯡꯈꯤꯅꯕꯒꯤꯗꯃꯛ x ꯑꯃꯁꯨꯡ z ꯒꯤ equation ꯑꯃ ꯐꯪꯒꯅꯤ equation 4 x z ꯌꯥꯎꯕ equation 3 ꯒ 4 ꯒ ꯑꯃꯨꯛ ꯑꯅꯤꯁꯦ adding ꯇꯧꯔꯗꯤ z ꯒꯤ ꯚꯦꯂꯨ ꯃꯥꯡꯈ꯭ꯔꯅꯤ x ꯒꯤ ꯚꯦꯂꯨ 3 ꯐꯪꯉꯦ ꯐꯪꯉꯤꯕ x ꯒꯤ ꯚꯦꯂꯨꯁꯤ ꯑꯃꯨꯛ 1ꯗ ꯁꯤꯟꯖꯤꯜꯂꯕꯗꯤ y ꯒꯤ ꯚꯦꯂꯨ 2 ꯐꯪꯉꯦ x ꯑꯃꯁꯨꯡ y ꯈꯪꯉꯦ z ꯒꯤ ꯚꯦꯂꯨ ꯄꯨꯊꯣꯛꯈ꯭ꯔꯗꯤ y ꯒꯤ ꯚꯦꯂꯨ 2ꯗ ꯁꯤꯟꯖꯤꯜꯂꯣ 2ꯗ ꯁꯤꯟꯖꯤꯜꯂꯕꯗꯤ y ꯒꯤ ꯚꯦꯂꯨ z ꯁꯤꯟꯖꯤꯜꯂꯕꯗꯤ z ꯒꯤ ꯚꯦꯂꯨ 5 ꯐꯪꯉꯦ